L&T S-Line Busduct installation video series. Introduction. Welcome to the L&T S-Line Busduct installation video series. L&T S-Line Busducts are type tested at various independent laboratories and conform to international standards like IEC 61439, Part 1 and 6 and others. To meet the industry's entire range of power delivery needs, L&T offers Busduct system from 250 amperes to 6300 amperes. Let's look at the technical specifications of L&T S-Line Busduct. The Busduct construction is of sandwich type. This means that the conductors are individually insulated and mounted, resembling a sandwich of conductors and insulation within the Busduct casing. Aluminium Busducts are available in the range of 250 amperes to 5000 amperes, while copper Busducts are available in the range of 400 amperes to 6300 amperes. The rated operational voltage for the Busduct is 415 volts to 1000 volts, while the rated insulation voltage is 1100 volts. The rated impulse voltage is 8 kV and 12 kV as per the requirement. The rated dielectric voltage is 2.5 kV for 5 seconds, while the rated frequency is 50 or 60 Hz. The pole configurations available are 3-phase 3-wire, 3-phase 4-wire with 50% neutral, 3-phase 4-wire with 100% neutral, and 3-phase 5-wire having 200% neutral with or without 50% internal earth, and also provision for mounting external earth. Each bus bar is insulated with a Class F insulation having a capacity to withstand temperature up to 155 degrees Celsius. The insulation material is UL listed multi-layer polyethylene terephthalate. 1.6 mm GI or 2.5 mm aluminum is used as enclosure material for aluminum bus duct, while 2.5 mm aluminum is used for copper bus duct. Epoxy powder coating is used for surface coating of the bus duct. The shade of paint used is RAL 7032. For windows, IP54 or IP55 protection is provided, while for outdoor assembled system, IP65 or IP66 is provided. The plug-in box is available in the range of 16 amperes to 400 amperes, and the tap-off box is available in the range of 16 amperes to 1250 amperes. The uniblock joint is provided with twin-headed maintenance-free nut. The bus ducts are tested for compliance for seismic zone 5 in accordance with IS 1893 and for high seismic qualification level as per IEEE 693. The assembly is tested with combination of vertical and horizontal orientation with mounting plug-in box in live condition. The bus ducts comply with fire resistance of up to 240 minutes in building penetration test as per required IEC standards. The bus ducts are also verified for resistance to flame propagation. The bus duct system comprises of several accessories. Let us look at all types of accessories and their use. Feeder. Feeder bus duct takes power directly from one source to another, usually from the transformer or DG set to switchboard or from one switchboard to another. The feeder can be supplied with a length between 500 mm and 3000 mm. Plug-in feeder. Plug-in feeders are used for power distribution through plug-in boxes. The plug-in feeder can be supplied with a length between 1200 mm and 3000 mm. Tap-off feeder. Tap-off feeders are also used for power distribution through tap-off boxes. Tap-off feeder can be supplied with a length between 1200 mm and 3000 mm. Vertical elbow. Vertical elbows are used to turn the bus duct root up or down if it is running on its edge when the bus bars are vertical. Horizontal elbow. Horizontal elbows are used to turn the bus duct root left or right if it is running on its edge when the bus bars are vertical. Vertical offset elbow. Vertical offset elbows are a combination of two vertical elbows and are used to avoid obstacles such as pipes, columns and beams. Horizontal offset elbow. Horizontal offset elbows are a combination of two horizontal elbows and are used to avoid obstacles such as pipes, columns and beams. Combination elbow. Combination elbows are a combination of vertical and horizontal elbows. They are used to avoid obstacles such as pipes, columns and beams, as well as to change the plane of bus bars horizontally or vertically as required. Vertical T-elbow. Vertical T-elbows are used to split one bus duct run into two runs going in different directions. Reducer. Reducers are used to decrease the current carrying capacity of bus ducts in the same route. For example, 1000 ampere bus duct rating can be reduced to 630 amperes using the reducer. Reducers can be used in vertical as well as horizontal power distribution systems. Flange end. Flange ends provide direct connection between the bus duct system and the transformer or DG set or switchboard or end feed unit through flexibles or links or direct connection. Flange ends can also be supplied as combinations with vertical elbow, horizontal elbow, vertical offset elbow, horizontal offset elbow and combination elbow. Expansion joint. Expansion joint is used in the system to accommodate the expansion and contraction of bus bars that can happen due to heat. Plug-in box and tap-off box. Plug-in and tap-off boxes are used to tap the power from plug-in feeder and tap-off feeders. Plug-in boxes can be plugged in and out, whereas tap-off boxes have fixed contact. Horizontal support. Horizontal supports are used to support bus duct when they are installed horizontally. Horizontal channel should be supported by vertical threaded rods and the gap between two supports should not be more than 1.5 meters. Vertical hanger. When bus ducts are installed vertically, the same should be supported with vertical spring hangers at each floor. First floor bus duct must be supported with fixed hanger. Wall flange and floor flange. These are used to close the wall or floor opening through which the bus duct is routed. Now, let us look at the tools required for bus duct installation. Torque wrench of 90 Newton meters and 150 Newton meters with socket. Spanner set for bolt sizes M6 to M14. Flat screwdriver. Tester. Measurement tape. Cutting plier. Rubber hammer. And spirit level.